All right, it's Monday, January 24th. 2 weeks until we're off, so that's good. That's really good. The packet I just passed out to you and the one that's posted online is notes for today, worksheet for today, and worksheet for tomorrow. So don't be overwhelmed by what you've got there. Posted in Schoology already is the answers for today, and some of the answers for tomorrow, but I'll post the rest of those later. So you've got all the assignments that you'll get that go with the test. All right, so again, fill in the blank notes. So if you're sitting at home, print that out so you can make your life a little easier. Functions defined by integrals. This is, I don't know. This is one of those topics where once it clicks, it's not bad. You start to see it and it makes sense. But man, it takes a little bit to get there. That's why I reshuffled the days to make sure we didn't see this the day before the test. See it 2 days before the test. Give us an extra day to let it sink in. The graph of a function f consists of a quarter circle and line segments. Okay. Let g be the function given by g of x equals the integral from 0 to x of f of t dt. So here's my picture of f, but g is the integral. What's another way to think of the integral, or what does the integral tell us? Or how do we evaluate the integral? Antiderivative is one way. Antiderivative usually works when we have an equation to actually antiderivative. So what's another way to think of the integral? Area under the curve. So this means area under f from 0 to x. And it may be helpful to write that every time you get one of these problems. It sort of forces you to slow down and think, okay, so g of x just means the area under f from 0 to wherever we're looking for. Yes?
Why is it the area under f and not the area under g?
Because it's the integral of f.
Okay, oh, yeah, okay.
So area under f from 0 to x. So g of 0, a couple ways you could do this. Well, I guess we'll do it both ways. So that just means wherever there was an x, right, wherever there was an x, we're going to plug in 0. So the integral from 0 to 0, would someone like to stop me now and tell me the answer? 0. Why is it 0? There's no area between 0 to 0. I'll spell it out a little bit, but area under f from 0 to 0, well, yeah, that's 0. That doesn't really even make sense. G of negative 1. Be careful, x is in the top, so you have to put the negative 1 at the top. Even though I kind of don't like that. Why don't we like that? Because the top's the smaller one. How could we fix that? Make it a negative. So I'm going to put a negative out front and say the integral from negative 1 to 0. You don't have to do that. You can go from 0 to negative 1. You're going backwards, so your area would be negative, which is what we're going to get anyway. So the area from 0 to 1 would be this little triangle here. 1/2 base times height. Or you could almost just look at it and fit that piece of area into that piece of area. And that area is 1. So be careful how you answer the question. The area is 1, but because we were going backwards, the answer to the integral is negative 1.
So that's base times height.
I did 1/2 base times height.
What is 1/2?
1/2, because that's the area of a triangle. Base times height. G of 2, integral From 0 to 2, f of t dt. Why don't you try that one? All right, part B. Now that, as if that wasn't interesting enough, now we're going to put a little bit of a twist on this. Find all values of x on the open interval -1 to 5 at which g has a relative maximum.
I feel like you're putting too many things together right now. Like, we definitely put this like
So, yeah, we haven't done this in a while. So forget the specifics of this problem. Where does g have a relative max? That's going back a ways, but g has a relative max
X equals 0?
when...
What?
No, give me the justify first, and then we'll look for it. G has a relative max
When it changes to a
Isn't it
fraction.
like-
When it.
when something changes.
When f prime goes from
Positive
positive to negative.
Okay, except now we're dealing with g. So when g prime changes from positive to negative.
That's so sad.
So be careful, our picture is not
Yeah.
g, our picture is f. So what we need is g prime. Well, g is equal to the integral from 0 to x, f of t dt. That's what we already know. I want to take a derivative of both sides so that g prime shows up.
Isn't prime just F?
And then here's the fun part of this problem. It actually gets easier rather than harder. The derivative of g is g prime. That's what we want. Now the other side looks really complicated, but hold on, it's the derivative of the integral. So what's g prime equal to? F of x. So that's really good news, and f of x is the graph. So let's go back and look at our reason now. G has a relative max when g prime, which is the same as f, which is our graph, changes from positive to negative. So that would be x equals 2.
And then these are all the words that we wrote, like enough justification.
Right, and the words we wrote, we've already justified it. Now, sort of the picture reason that is because G is the area that we're sort of accumulating as we go. So we accumulate area. Well, what's happening at x equals 2 that makes x equals 2 a maximum? In terms of area. Area accumulation. So from 0 to 2, we're adding area. What happens after x equals 2? We start subtracting area. So that means at 2, there's a maximum area, because after that, we start subtracting it. So that's sort of the visual of what's going on. But so it helps if you understand both, but even if you only understand one way, that's fine. Part C. Find the absolute minimum value of G and the value where that occurs. Well, again, I think I would do the justify first. G has a relative min
Wait, isn't it
when G prime...
isn't it absolute?
Oh, it does say absolute min, so we'll need to check the endpoints. Absolute min means check the endpoints. But we also need to check the relative points. Good catch. G has a relative min when G prime changes negative to positive. But we already figured this out. I should box this because this seems important. So G prime is the same as F is the same as the graph. The graph is F. So where does our graph change from negative to positive? Nowhere. So there are no relative mins. That's good. That means all we have to do is check the endpoints. Again, from the graphing perspective, we add area, we add area, we add area, and then we subtract area. So yeah, there's a max there, but there weren't any mins. So endpoints, because of absolute. Absolute means check the endpoints. So we need g of -1 and g of 5. And this is pretty common in AP setup questions like this.
Oh my gosh.
Why, oh my gosh?
We
We already
already found
found those. G of -1 was -1. G of 5 was pi minus 4. Uh-oh. Pi minus 4 is negative 0.9-ish, right? 3.1 minus 4. And so we're looking for which one's the smallest. So which one's smaller, -1 or -0.9? -1. So the absolute minimum is -1. Oh, I don't like this problem. The absolute minimum is -1, and it occurs at x equals -1. I mean, it's a good reason I don't like it. Like if you get them mixed up on whether the x or the y, they're the same for that one. But the minimum is the y value, the location is the x value. Part D. Find the x-coordinate of each point of inflection on the graph of G. Justify your answer. Well, let's justify our answer first and then go from there. So how do I know where G has a point of inflection? Yep, when G double prime changes signs. G double prime. I don't have G double prime, but I have G prime. So if I take the derivative of both sides of, or really all three sides of this, that means G double prime equals, what happens when I take the derivative of f? F prime. And what does that mean about the graph of f? The slope of f, or the slope of the graph. So let's fill in our, so we want when G double prime changes signs. That means when f prime changes signs. Or, maybe best of all, when the slope of f changes signs. Because I'd like to get it in terms of f, because that's what I know. F is the graph. So talking about G doesn't help me a whole lot. So I sort of translate that into f. So where does the slope of f change signs? X equals 0. It goes from positive to negative. Anywhere else? X equals 3 changes from negative to positive. So yes, this is a combination of two things that we've already done. One goes way back. Hopefully you remember it well enough. It seemed like you did. And the other is more recent. What we did Friday was the derivative of an integral gets you back to the original. But show those steps. If you'll show those steps, it makes this a lot easier. Write out G prime equals f equals graph. G double prime equals f prime equals slope of f. Let's try number 2. These start being all the same, which is good. It's just more practice. Let G be a differentiable function. Oh, here we go with the uppercase, lowercase stuff again, so be very careful. G is the area from -1 to x of little g. So I'm going to write that out. I mean, that's what I'm thinking. I may as well put pin to it. Area under little g from -1 to x. Again, you don't have to write that out, but you need to think that. So for now, we're going to write it out. It forces us to slow down and think about things. So this one has a different starting point for area, but that's okay. Big G of 5. That means the area from -1 to 5 of little g. Area from -1. By the way, this one couldn't start at 0 because we'd be midway through a circle and we don't know how to do that. So we've got to go from -1, the half circle, all the way to 5. Or a quarter circle, I guess. Hey, we already did that area. Right? That was pi. That's the same shape as earlier. The area is pi. Why am I hesitant? What's going on here? It's negative. So some people don't want to label it negative because they're insisting that no area is negative, which is true. Other people are like, well, I know no area is negative, but that's not the context of this problem. This problem is integral, so I'm just going to go ahead and call that area negative pi. And that's fine. I think that's how I would do it, so I don't forget about it later. Not done yet. That was just that piece of it. And then this triangle over here. 1/2 base. Careful, the base isn't 5 long. The base is 4 long. Height is 2. So 1/2 of 8 is 4. -5. Negative pi plus 4. Well, I guess since I did it, I may as well label it in case I need it later. I don't think I will, but... Alright, g of -5. Integral from -1 to -5. G of t dt. What do you want to do first for that one? I would flip them. Again, you do enough of these, you get to where you can go backwards and just call it negative, but I don't think we're there yet. So I'm going to flip them to put it sort of in the right order so I can move left to right. And I'll just make sure I get a negative outside. So another triangle. Base times height over 2 be 3 for the triangle. That quarter circle is still negative pi. And I would just leave the answer like that. If you want to clean things up and distribute that minus sign, that's fine. But I would leave it like that. Alright, relative max of capital G, so that would be where G prime changes positive to negative. Well, be careful, but go ahead. It's where big G prime changes positive to negative. So what? It is. I do want to know where big G prime changes positive to negative, because that would be the relative max of big G. But what's big, and here's where you're headed, I think. What is the derivative of big G prime? Little little g,
Yeah, that's what's
which is the graph. So I want to know where big G prime, but that's the same thing as little g, changes positive to negative. So where does that happen? Where does it change from positive to negative? Yeah, just -3. Again, if you really want to think conceptually about what's happening, that means as you move left to right, you're adding area until you get to -3. And then you start subtracting area. So that means -3 is a max, because that's where you change from adding area to subtracting area. Relative min of big G is where big G prime changes negative to positive. But we just said that big G prime is the same as little g. So where does little g change from negative to positive? At x equals 1. Again, I've said this before, haven't said it in a while, but I always like justifying your answer first because it tells you what to look for. Part C, determine all points of inflection of G. Justify your answer. Well, justify first. G has a POI. So regardless of this particular example, G has a POI when G double prime changes signs. But, lose track here. What's big G double prime equal to? Little g prime, which is the slope of little g. And every year there's people who try to do these problems without writing out those 3 steps. And I mean, sometimes they get them, sometimes they don't. But if you would just take the time to write out what big G prime is and what big G double prime is, I think it makes the problem a whole lot easier. So what I have written is enough, but just to make it extra clear, I'm going to even write slope of little g under there. So now it's really clear what I'm looking for. Where the slope of g, little g, changes signs. So that would be at x equals -1 and x equals 3. Part D, we haven't done one of these yet. Big G prime of -1. But what's big G prime equal to? Little g. So instead of G prime of -1, let's find little g of -1. How can I find little g of -1? Look at the graph. So these are really easy problems to do once you get the concept down. So g of -1, just looking at the graph, what's that equal to? -2. So yes, it's asking for the slope of big G, but that's not really how we're working the problem. We've translated big G into little g, and now we're dealing with the graph. Example 3. Kind of the same thing. Capital F equals the integral from 0 to x of f of t dt. So again, I'm going to write it out. This is maybe overkill, but that's the area under f from 0 to x. Where f is graphed above. So be careful, that's the graph of f, little f, not the graph of big F. All right, I want to skip A because time and because that's just area from 0 to 2, area from 0 to 4, and so on. Let's jump down to part B. F of 0. Well, f is the integral from 0 to x what's that one equal to? I can stop there on that one. The area from 0 to 0 is going to be 0. F of 2 require a little bit more work. The area from 0 to 2. Be careful. What's that area? Yeah, well, it depends on how I ask the question, I guess. The area is 4. The integral is negative 4. You can label it either way, as long as you're careful. I would label it negative 4. Let's skip f of 7 because I really want to get to, and we can all out skip c. Like that's beyond what we want to worry about. So we're going to omit c. You don't need to know how to do c. We don't need to write a piecewise function. Part D. Where does capital F have a local maximum? Now, it doesn't ask me to justify my answer, but I think I need to justify my answer, at least in my head, so I know what I'm looking for. So, where does capital F have a local max? Like, just in general, not for this problem, how would I justify capital F having a local max? No, they're not. Relative and local mean the same thing. So where big F prime changes positive to negative. Big F. I like this problem because we've got a little space to work over here. There's big F. That means F prime is equal to, big F prime is equal to little f. And while we're at it, we may as well do, because we'll probably need it later, big F double prime is equal to little f prime. So f is the graph, f prime is the slope of f. So that's probably what we'll be looking for. So I want to know where little f changes positive to negative. So that would be at x equals 5, and that'd be the only place. Okay, we've done that one before. What we haven't done is E through H. So, well, we've sort of done them. On what intervals is f decreasing? Well, again, think justify. Capital F is decreasing when capital F prime is negative. But what's capital F prime equal to? Little f. So little f is negative. So all I'm looking at is on the graph is where f is below the axis. So it's turned into an easy question. So that would be from 0 to, 2 point something. Let's see. That slope is up 5 over 2. No, I don't like it when they do this to us. Up 5 over 2. So that means up 2.5. What is this? I think it's 0.8 because it doesn't land on the. Or is it 0.6?
That is for sure
0.8. So 0 to 2.8. I don't like that it doesn't land evenly. It makes us do extra work. And then from where else? 5 to 10. All right, bell's about to ring. Your assignment is the next worksheet, worksheet 1. Worksheet 2 is the next day's worksheet. It's really just more practice, the same stuff. So I think tomorrow's worksheet is pretty quick. I think you'll be able to, or today's worksheet goes, I think, pretty quick.